All right, looks like we'll get started. Welcome everybody to Long's Coffee Break. Want to thank everybody for taking the time to join us today. My name is Ryan Netbalski. I am a sales engineer in the Colorado Springs and Southern Territory in Colorado. I've been with Long for roughly 9 years now. I do feel very fortunate for the fact that I get to work for a company that has in a long line of different types of manufacturers that allows me to work on many different projects. A lot of those being hospitals, schools, commercial buildings, grow facilities, and natatoriums or indoor pool design. Which leads us to today's conversation of indoor pool designs. We have Jeff Peterson with us today, who is with InEvent. InEvent being a custom manufacturer for air handling units, who has a specialized group dedicated to natatoriums and indoor pool classification. So, Jeff, thank you for being with us today, and I appreciate you taking the time, and hope you can help us out.
Okay, great. Yeah, as Ryan said, I'm Jeff Peterson, and I'm with InEvent. We're based out of Minneapolis, Minnesota. My role is I'm an area sales manager. So what that means is when you guys reach out to one of the Long team members, I'm the guy at the factory that they reach out to say, hey, help us with the design or put quotes together, that kind of thing. And then someday when we're all seeing each other in person again, I'll be the guy that shows up at your office to give lunch and learns and that kind of thing. So, our Zoom meetings will have to suffice for now, but I look forward to eventually meeting you guys all face to face someday. I've been with InEvent for 8 years, April 1st. Before that, previous life, I was with a local trained sales office. I'm an Iowa State graduate, so if anybody on the call is a former Cyclone, we have that in common. I imagine very few of you are. Give you a general idea of who InEvent is. If we're a new company to you guys, if you haven't heard the name before, we're here to talk about pool applications today because we have a very unique value-added custom approach to that specific application. But in general, we do custom air handlers, and we have the ability to do custom refrigeration as a part of that and custom package controls. We focus on energy recovery, be it sensible plates, enthalpic plates, energy recovery wheels, heat pipes, kind of you name it, right? We're very flexible with that. We're based out of Minneapolis, Minnesota. With respect to pool applications, we've done over 1,000 pool projects over the last 25 years. And one of our strongest territories is actually Long's territory in Colorado. Our solution actually performs the absolute best in you guys' climate. And I'll go into that in a little bit. Our relative size is about $60 million. So we're one of those, medium-sized HVAC manufacturers. So what we want to talk about today, we don't have a ton of time, but I want you guys to understand what are the application differences? What makes a pool application unique versus an office, a school, those types of typical applications. There's some key things that you want to keep in mind and key problems that you're trying to solve with your design. And you want to make sure that you're aware of those so that you don't get yourself into trouble with a future problem job. To understand that, it's important to kind of understand what are the different options out there, right? We have a unique, but not exclusive approach to how to do this. And there is a conventional approach. So I want you to have a level of familiarity with that so that you can understand what are the differences between the conventional approach versus how InEvent does it, and then what are the benefits and drawbacks of each type of system. So to get into the application considerations, you think of a pool space, right? You've got this large body of water in an indoor environment. The name of the game is constant dehumidification. You're always trying to dehumidify that space year round. Different manufacturers have different ways of dehumidifying, and I'll get to that in a couple of seconds here. But really, the major differences are, well, number one, what kind of a space temperature are we talking about? In a comfort cooling application, you're going to maintain a space around 70, 75 degrees, anywhere from 30 to 50% relative humidity. Well, a pool space is much, much warmer, right? So typical space air conditions are anywhere from 82 degrees to 84 degrees. Well, why do we maintain it so much warmer in a pool space? Well, number one, occupant comfort. You think of getting into a pool and then getting out on the deck, you're wet, you're walking around. You don't want it to be 70 degrees. You'll be freezing if you do that. The other thing is if you have a really low air temperature, the water temperature is generally controlled to about 80 degrees, and it depends on the application. The different types of pools might have different temperatures. Obviously, you've got spas and things like that. They're going to have higher temperatures. But the general rule of thumb is for your typical pool in a YMCA or in a college university, you're about 80 degrees. You don't want a giant delta between that air temp and that water temp. If you had a really, really cool air temp at like 70 degrees, and your water temps at 80 degrees, you're going to drive the evaporation rate way up. And that's going to put a heavier load on the HVAC equipment. And it's going to cost more to constantly be filling water back into the pool. So it's constant dehumidification. The biggest key issue that comes with pool projects is something called chloramines. Well, what are chloramines? We all remember when we were younger, you go on a family vacation and you go into the hotel, you step in the lobby and you can smell the pool, right? As a kid, you get excited about that, but knowing what we know in the HVAC world, I'm here to ruin that for you. It actually means that the pool water chemistry in that hotel pool was really, really bad. It means the chloramines had built up. Chloramines are what you get when free chlorine that's injected into the pool system, into the pool water, grabs onto an organic material. So the most pleasant example of that would be human sweat. And when those grab onto each other, number one, the chlorine's disinfecting that, which is good because it makes the water cleaner. It evaporates into the air, which is what you want it to do, right? You want to evaporate out of the water, go into the air, and then get exhausted out of the system. Well, if chloramines build up in the space, there's two major issues with them. Number one, they're very, very nasty from an occupant health standpoint, right? So you've got people that are breathing this air in, and if there's a lot of chloramines built up in a pool space, number one, that pool smell is very apparent. And number two, people can have issues with swimmer cough, eye irritation, lung irritation, and all sorts of nasty things. And there are plenty of horror stories out there to document that, but it's a very, very real problem. Aside from the occupant health concerns, you can have major structural issues. So chloramines, in addition to being irritants for occupants, are also highly, highly corrosive. So what that means is if they find a metal surface inside of the natatorium and they condense on that metal surface, they immediately start corroding, eating away metal. And again, there are plenty of horror stories associated with that. So indoor air quality, the temperature and the dehumidification load and the conditions that we're trying to maintain, and then preventing the buildup of chloramines are major, major issues with these applications. The other things that you want to keep in mind is how complex of a system do I want to design for this application, right? Who is my owner? What is the space going to be used for? How important is maintenance, reliability, energy efficiency, and all those kinds of things? So those are some of the miscellaneous considerations that you want to take into account as well. So I'll give you a quick overview of the conventional approach. What is kind of the industry standard developed in the 80s and kind of into the 90s of what was out there. It really centered around a focus on mechanical cooling to dehumidify, right? You're going to draw moisture out of the air by cooling the air down to a certain point, condensing that air, letting it go through a drain pan, and then you've got heat of rejection. The major benefit of that system was they have that heat of rejection that they could either put to an air-cooled condenser, so you're throwing that energy away, or you put it into a hot gas reheat coil downstream to dehumidify, which we're all really used to that. But the key benefit is, well, hey, why don't we take that energy and why don't we heat the pool water with it? So you take heat of rejection from running your compressors and you heat pool water with it. That's kind of the flagship major benefit of the mechanical dehumidifier approach. The major drawbacks of that system are that they're really only focusing on cooling the return air, and bringing in outside air is kind of an afterthought. So those systems are really designed and optimized around bringing in the ASHRAE prescribed minimum amount of outside air. And it's well documented that ASHRAE minimum does not do an effective job of offsetting issues that can arise after installation with chloramine buildup. And that is the single most frequent issue that arises with pool applications, is the issue around chloramines. Regardless of who you ask, they would all give you the same answer. So while the conventional approach is a pretty good approach and it can maintain good space condition and it can have that benefit of heating pool water, you think about running compressors and you think about when you want pool water heat the most, it's going to be the coldest time of the year. Does it make sense to be running mechanical cooling in February when the outside air temperature is 10 degrees? Not really, right? So how does InEvent approach these problems? Well, our focus is on introducing more outside air than the ASHRAE prescribed minimum. Every unit is custom designed for the specific application, again, because we're a custom manufacturer. So we engineer that specific selection for your specific project. But what we're doing is we're introducing substantially more outside air into the system. Well, what does that mean for efficiency? Well, because the outside air dew point is actually at a more favorable condition than the space dew point that you're trying to maintain, it's extremely efficient, right? We don't need to run mechanical cooling for dehumidification purposes because we can offset that entire dehumidification load just by introducing outside air. Now we're doing it in an efficient manner because we're using a sensible only aluminum plate heat exchanger to do airside energy recovery. So especially in a place like Denver, you know, if your dew point is ballpark like 58 degrees, when you compare that to that space temperature and space humidity I talked about in summer, 82 degrees at 60% relative humidity, that's a 66 degree dew point. So you use that 58 degree dew point outside air to dehumidify that space. So the benefits of it are we're running mechanical cooling less. The only reason you need mechanical cooling in Colorado is for sensible temperature control. And that would be when it's the dead of summer and you're at your design dry bulb day, not your design dew point day, but it's like over 100 degrees. You don't want to overheat the space in those conditions. So we will put a sensible only cooling coil on there to temper the air and bring it down to a better target temperature to make sure that the occupant comfort's in the right range. But the major benefit is that indoor air quality. The one variable that engineers and reps and manufacturers can't control is the owner going to do a good job of maintaining pool water chemistry or not? And that directly relates to, will chloramine buildup be an issue or not? The more outside air you bring in, the less likely that that is going to be an issue. So to kind of look at our airflow diagram, what does an InEvent system look like? It's very simple, and this is one of the benefits of it, right? You walk up to an InEvent unit and you're not going to be confused about what is this component doing, what is that component doing. We're bringing in outside air, passing it through the plate heat exchanger, and then we mix it after that outside air gets preconditioned through the plate heat exchanger with the return air, right? You don't want to throw all of the energy that you've got from the pool out of the system because that's 82 degree air, right? So if it's cold air outside, you don't want to have to increase your heating load by throwing all that air away. So in summer, it generally equates to about 50% of nominal airflow coming in at the higher dew point, passing through the plate heat exchanger, remixing with the pool air, and then either heating or cooling depending on the season. In winter, because that dew point outside is so much lower, we can actually scale the amount of outside air back a little bit. We can use less of that lower dew point air to offset our dehumidification load, but we're still bringing in enough to effectively keep the indoor air quality at an acceptable level. We're always maintaining the space at a slight negative. That's an industry standard. You want to make sure that air from adjacent spaces to a pool leaks into that space. You don't want that chloramine-laden air to leak out into lobbies or office spaces or party rooms or anything like that. So in conclusion, if you're working on a pool job, keep in mind it's different from a comfort cooling application. One of the things that I hear very often when I'm in a territory and visiting engineers is they say, hey, we only work on 1 or 2 pool jobs a year. It's a great opportunity to lean on InEvent, because we are the experts. We have a lot of installations, a lot of experience with these applications. And when you only work on 1 or 2 a year, it's kind of hard to keep in mind, what are all the things that I've got to be aware of? So we can be a good resource for that. Keep in mind the conventional approach, while it is a good approach, it comes with certain liabilities associated with indoor air quality. And there is a more reliable way to do it. There's a more mechanically efficient way to do it. And that's using our airside energy recovery approach. And if you need more references, InEvent's got a website. We're always available. Your long salesperson is always available, but we do have a lot of industry articles, some more in-depth webinars, and design assistant application guides available on our website under a section called Breathe. So you can feel free to go on there and kind of familiarize yourself with the resources that we've got there as well. I appreciate you guys' time. Thanks for spending the time with me here today, and I look forward to working with all of you in the near future.
Thank you, Jeff. That was fantastic. Do appreciate you taking the time to be with us today. If you have any additional questions, please reach out to your long sales representative, and we can get you lined up with any other questions that you may need. I want to thank everybody for taking the time today to join us for our coffee break, and hope everybody has a great day. Thank you.